Good day. See, I actually remembered not to say good morning to you.
Good day.
Yeah.
Actually, the same day as yesterday.
For us, it is, but we change clothes. Why do we even bother? Why don't we just? Why do we even
I
go?
don't know, but I did make sure that I put on some nice big earrings since I missed the earrings last time. I know you guys were concerned, so I wanted to make sure,
So
that
you
I'm
get
holding.
the full effect of the earrings and all.
Yep.
All right, this is a pretty short lesson. It's solving equations and inequalities with absolute values. We talked about solving equations and inequalities earlier, so it's much like that, but not the same. So we'll just jump right on
You
in.
say, but not the same.
It's the same thing, but not the same. So I'll put you over here out of the way because you're what? Absolute value really, I don't know. Sometimes things come out of this mouth and you just have to. I mean, like, is what happens when you live with a corgi. A corgi, thank God corgis are cute, all right? Because they're annoying. Anyway, absolute value is distance from 0 on the number line. So when I say the absolute value of a number is 4, that's telling you I'm 4 spots away from 0 on the number line. Well, there's 2 numbers that are 4 spots away from 0 on the number line. There's 4, and there's also -4. And we basically do that with equations as well. So whenever I have an absolute value equation, it's always going to break down into 2. And I think I did this analogy before. I love these problems because it's like getting 2 pairs of shoes for the price of 1, which I didn't need. I need a pair of shoes, but anyway. So where on the number line, and I use that example for, look at you trying, you did not draw that line. You used the line tool. You could
I actually drew a really ugly line and I was like, oh, I'm gonna undo it.
So there's a point here at 6. Oops, maybe I should back up and get my pen tool because there's a point here at 6 and there's another point at -6. And that really is, so really what all you have to do with this first one is say x is equal to 6 or x equals -6.
And if you're wondering right now if the number line is part of the work you need to show, it's not. I just put it there so that you could really easily see that this question, when it's as simple as what the absolute value of x is equal to 6, when you're talking about it being distance,
Yeah, it's, I don't expect to see any work here. I do want to see a little more work if the problem's a little more complicated, like the one on the right side. So I would have to you basically set the stuff in the absolute value bars equal to the positive of the number and the negative of the number. Right. So in this case, I'm just going to break it down. It's like finding that 2 pairs of shoes for the price of 1 deal again. So I'm going to.
I always think about if you see absolute value, you should always think 2 cases, positive and negative. So he's just giving you the 2 cases right now. This first one is on the positive side. This next one is on the negative side. I might have done it opposite just because negatives on the left, positives on the right. But it honestly doesn't matter at all which order you write your cases in. He's going to change it.
Because one thing I've learned about Miss Young, it's just easier to do things her way. I mean, really.
Yeah. Can you come hang out tonight and talk to my husband about that?
No, I'm not going to do that because, well, actually, if that's what you want me to do, I'll do it because I do whatever. Sorry. Yeah, I'll do whatever you tell me to do. And when I solve them, I get -9 and 7. Okay? So you break them down into the 2 cases, and then you solve each equation simultaneously, or separately, not simultaneously, separately. Okay?
Although if you are ambidextrous and you can solve them both simultaneously, that would be sweet. And please video yourself and send it.
Yeah, we've been doing problems together. So kind of like, together we make one ambidextrous person. Okay, now there's a couple caveats. You want to get the absolute value bars alone before you split it up, okay? So in this case, I have other things I probably should have had at times or something, one of them times, but whatever. I just picked problems that made me feel pretty. So I got to get rid of this -3, this 3 first.
You know what I can do? I can add a 2 on this problem, and all of a sudden it has a multiplication in it.
If you want to do that,
you're welcome.
Harder. Okay, so I'm going to subtract 3 and get, let's see here. Now her new problem. I hope the problem gets real ugly because of that too, by the way.
It's not going to.
I hope so. And then
I
I go,
did it. I did it in my head before I picked the number.
wow, okay. And basically, I'm trying to make it be like the problem on the previous slide, and this equals to 6. Once I get that absolute value bar isolated, then I can do the old split arena. Don't split until it's all low.
You
And then,
should be able to think in your head, the distance is equal to 6. As soon as you can think the distance is equal to 6, then you can say, okay, that now it's got to be -6 and 6. That first line, you don't have a distance yet. You have 2 times the distance plus 3. That's crazy sauce. Get absolute value by itself first.
did you say crazy sauce?
Maybe.
Maybe.
Like applesauce, but not.
Okay, well, then that means we have x is equal to 8 and what, -4? But I didn't think this.
Negative, yeah, -4.
Wow, you were going to try to find me the mistake. I never make mistakes. Okay, you want to try the other one, and you want me to make it harder for you or no?
No, it's already going to be hard.
Yeah.
Yeah, it's going to be super difficult.
Real hard. This one's going to be super. Oh, I know why I picked this problem. Now I remember.
Yeah.
That's the reason I picked this problem. Okay. Yeah, I have a really purpose. I actually do know what I'm doing sometimes, but not like right now. What happens when you write 17 lessons in one weekend while your wife is grading AP?
Mr. Bobby has no life, in case you guys wondered. I was in Kansas City hanging out all weekend, and he was like, I've written all these math lessons.
I literally, this is like I don't know, it's mid-June, and my wife was grading AP exams for 4 straight days, and I had nothing better to do than write college algebra lessons. I literally wrote like 10 college algebra lessons in a 2-day period. It's ridiculous.
Yes.
Okay, now I could split this up as absolute value of, or I could break it down. Wait a second. I got -5 over there because I want to like do positive and negative. But if you keep in your mind what I said at the very beginning, absolute value is distance. I got a problem. And this is why Miss Young was laughing at me.
So the problem here is that you've got distance equal to -5, and that's not possible.
And that's going to cause me some problems, okay?
Yeah.
Their absolute value is always going to yield a positive solution. So if I try splitting this down, I can break it into x plus 5 equals 5 and x plus 5 equals -5 and get answers, but they're going to be wrong, okay?
Because one of your answers is going to be, let's say, -10.
Yeah.
-10 plus 5 is -5. But then you have to plug it back in, or not plug it back in, but take the absolute value of it, and it's going to go positive.
Yeah, and I ain't got no way of getting -5. So if I ain't got no way of getting an answer, what's my answer? Well,
your answer is that there isn't an answer.
Sometimes the answer to life is that you just can't do it. Okay?
That was like that time I tried to run the sub-4 marathon, and my body was like, no.
Not going to happen.
No.
No.
Absolutely not.
Yeah. So, all right. And I'm not going to play professional football. I'm almost 50 years old. That dream is done. All right. All right. So, anyway. Sadness. Need to pause. All right. Let's move on. Oh, all right. So, moving on to absolute value inequalities. Again, keep in mind that distance from 0 is our definition of absolute value. So what this is saying is if I have an absolute value less than 0, then I need to be like stuck in closer, okay? So in this problem, I have absolute value expression being less than or equal to 17. It means I can't go more than 17 spaces from 0. It's like being grounded, okay? And I know none of you have ever been grounded. Neither has Miss Young, but I did some things I probably shouldn't have as a small child.
One time, actually the only time I've ever been grounded in my whole life, I was 14, I think, and I was trying to sneak out to my friend's house who had a pool down the street, and we were going to go like 3 o'clock in the morning swimming, and I fell out of the window. I fell out of my window, which was right underneath my parents' window, and like screeched, woke them up, got caught.
That's what happens when you try to sneak out. That's
Yeah.
why I like having dogs. I don't have to worry about dogs sneaking out. I just have to worry about them being on the road.
Yeah.
So
Yeah.
anyway, when absolute value is less than a number, we want it to be within those numbers between the positive and the negative. So I got to take this expression 2x plus 7, or sorry.
So I'm going to break in here for just a
All right.
second. Just to give you guys a visual of what he's saying, if we're going to be a distance less than 17, then we could be a distance of 16 or 15 or 14. What we can't do is we can't be a distance of 18, because that would be a distance greater than 17. And so from this direction, we need to think about the fact that we want to be less than 17. And then we have, remember, it's absolute value means that we've got that negative side too. And this is where we have to be careful, because if we're thinking about a distance less than 17 here, okay, this negative 16 is less, this negative 15 is less. But if I go outside of it, like to negative 18, then all of a sudden I've gone a distance greater than 17, and I'm trying to keep it less than, which means the other inequality needs to be greater than that negative 17. So you're not just going to find that you have a negative in this case, but also that your inequality flips.
So we want to be locked in between negative 17 and 7. That's why we're talking about being grounded, not just because we're reminiscing about being naughty children. Okay.
They want to hear all about my life story, I promise.
Yeah, apparently I didn't know that you were grounded as a 14-year-old. I've lost all respect for you.
Shut up.
We have solved inequalities like this before, back in, I think, chapter 1. So now we just do whatever we do, but do it to all three parts. So I want to get rid of the 5. So I'm going to add 5 to all three parts of my inequality. And then I'm going to have to divide by 2. So I'll get negative 12 is less than or equal to 2x less than or equal to 22. And when I divide everything by 2, I'm going to get negative 6 is less than or equal to x less than or equal to 11. So our graphic was really talking about that entity as an absolute value. But after I solve that entity, I end up being locked between negative 6 and 11.
Yeah. So yeah, not to confuse you, because this was an explanation of what a distance less than 17 looks like. Mm-hmm. And this is actually where your solutions will lie. It will be all the numbers between negative 6 and 11, including negative 6 and 11. So if I say pick a number like 0 between negative 6 and 11 and plug it in, I would get 2 times 0 is 0, minus 5 is negative 5, but the absolute value of negative 5 is 5, and that's less than 17, so I'm good to go.
Yep. And the exact opposite happens when we have the absolute value is greater than a number. Instead of being trapped between the two, we want to be beyond it, or in the number line that she drew earlier, we'd be on either tail. So we want greater than the positive, or less than the negative. And on the number line, it would have looked like this part out here and this part out here. And we end up with 2 different pieces.
Yeah. Okay. So he's saying if the absolute value were greater than 17, there's stuff inside here, then you would have to go on the outs.
And you're going to have to have 2 parts and solve each of those parts separately. Okay?
Right.
So not a big rocket scientist kind of deal, but so let's do one of those just for sake of completeness. We have an absolute value expression greater than 18. I think I threw in a little wrinkle here. They come out in the wash. But I'm going to take the 6x. I'm sorry. Pick my pen up again. So we're going to take 6 minus 3x and say that it's greater than or equal to. Oh, no, it's not equal to in this one.
It is not.
It is not. It's happened, so. And the other one would be 6 minus 3x is less than the negative.
And Notice that at that point, the absolute values are dropping off of the problem. It's a really common mistake for students at this point to keep the absolute value bars on the problem. But actually, the whole point of writing the two cases is to drop the absolute value bars because we can't move anything in or out of them.
Now I have a little wrinkle here because I'm going to divide by -3. In a previous video, we talked about when you have inequality, you have to do the old flipperino. Had something to do with your ex-girlfriend or something, or whatever Miss Young said.
I don't think that was it. That was for transformation.
Oh yeah, that was for transformations. Yeah, this was just the old flipperino.
Yeah.
Okay. And then same thing on this side. I'm going to flip. The nice thing here is it's going to happen on both, so that it's still going to end up working. So let's see, -24. When I divide by -3,
Flipper, flipper, flipper.
flipperino again. Oh yeah, these people probably think we're crazy.
We are.
Okay, so x is greater than 8 or
I'm
less.
glad you're okay with it.
Whatever. Okay. And
Should
that's
we talk about the word or and the word and, or no?
yeah, we can if you want. This, I mean, this actually makes sense because if you think about this part right here is going to be opening to the right. Okay. Even though that was the less than the negative when I did the flip it, that's going to be the part that's opening to the right. And then this part over here is going to be heading to the left. Now the or and the and means both of these both parts need to be solved simultaneously, or means either one of these could be the case. So these two won't overlap. So or means it could be in this part or this part, either one. There's two different regions of solutions. So is there something else you wanted to say about that, or?
No, I just, we used two different words there, but we didn't talk about why. So.
Okay. So what else? Is there anything else on?
I think that's it. I think that we have given them the sum total of everything they need for whatever chapter this is.
Yeah, this is 3-5 that ends module 2 and completes the chapter 3 units. I know they're all a little bit off. So I hope everything's going well for you, and have a groovy day.
Bye, guys.
Bye.